when we have either a function that looks like this, we would say that I have both a relative and an absolute min right there, right? Would you agree?
Yes.
Yeah? Yes? Are you with me? Yeah? Because it's the lowest point on the graph, and both arrows point up, so we'll never go lower than this point. Similarly, if the parabola is pointing down, we'll have a relative and absolute max. Sometimes you will have absolute maxes, sometimes you won't, in open intervals that go from negative infinity to infinity. If you close off those intervals, like if you do a closed interval a to b, then what extreme value theorem says, and you don't have to quote extreme value theorem, but if you've got a continuous function on a closed interval a to b, so let's say I had this polynomial and I cut it off at 2 points, here and here. I closed my interval. Then I will definitely have an absolute min, and I'll definitely have an absolute max. Does that make sense? Right here, we still have relative mins and max. These are relative. But relative only happens on the inside of an interval. We will do absolute maxes and mins can happen on the outside and on the inside of an interval. But if you've got a continuous closed function, then you will definitely have an absolute min and definitely have an absolute max. If it's not continuous, however, for example, if I took an let's say I took a rational function and it went like this, right? And I closed my interval off at 2 endpoints, would I have an absolute min or an absolute max? Not necessarily, right? So that's why it's the continuous has to be a part of it too. Is if it's not continuous, it doesn't have to have an absolute max or an absolute min, because it could go to infinity and an asymptote somewhere in between your interval. Okay? Most of these times you'll see these in word problems where they will give you a closed interval and they're asking you for max of something or min of something. We'll practice those next class. But let's say I just give you some equations and I ask you to find absolute extrema. Well, remember we said they could happen at relative maxes or mins or at endpoints. So the first thing you always want to do is you want to start by finding your critical values. So this would be 8x minus 12. And we set it equal to 0 because I want to find my critical values. So x equals 3/2. Okay, so our only critical value is x equals 3/2. Now we do a table of values, x and f of x, where we include our 2 endpoints, 1 and 3 on the ends, and then we put whatever critical values we have right here in the middle, in between. If you have a critical value that's not in between your 2 endpoints, don't include it because we don't really care what happens there. Okay? Then you take 1 and you plug it in here, and you get 4 minus 12 plus 10, which is 2. And you'll take 3/2 and you'll plug it in here. Just for time's sake, I'm going to tell you that answer is 1. And then you take 3 and you plug it in here and you get a y value of 10. Okay? So now that you have a chart and you know that this is a continuous function, then we can say that I have an absolute max where? At 3/2. At 3, absolute max is 10 at x equals 3, or if you want to do the ordered pair, you can do the ordered pair too. And we have an absolute min is 1, at x equals 3/2. Okay? Yeah?
Oh yeah, no, never mind. Sorry.
Yeah. You switched them. Okay. Let's try 2. First find our critical values. 2/3 x squared plus x to the negative 1/3 times 2x plus 1 by chain rule. Let's rewrite that. 2 times 2x plus 1 over 3 times x squared plus x to the 1/3. Always like it as a singular fraction so that we can figure out what's going on. Okay, so like we said before, we have to set both equal to 0, top and bottom. So top equal to 0 would be x equals -1/2. Bottom equaling 0 would be x equals and -1, yeah. You factor it. Okay. All right, make a table. X, f of x. -1, 2 are my bounds, so we'll put that at the end. And then any critical value that lies in between, -1's already on there. We need -1/2 and 0. Okay, we plug -1 in, and we get 0 into the original. We plug -1/2 in, and we get, I'm just going to tell you, cube root of 1/16. We plug 0 in and we get 0. And we plug 2 in and we get cube root of 36. Okay. Absolute max. Is cube root of 36, right? Cube root of 36 at x equals 2. And absolute min is 0 at x equals -1 and 0. So 2 locations that we have an absolute min at. Okay? All right. 3 and 4 do not have closed intervals. So what we do is, instead of doing a chart, we do a number line. So we'll find the derivative. Set it equal to 0. So x equals -1. And then since I don't have bounds on my interval, I've got to do a number line instead. So -1 f prime. Test a value on the left and the right hand side. So the left hand side, I'll choose -2, and that will be negative. And then I'll choose 4, and that would be positive. So f prime is going from negative to positive, which means that f is going from decreasing to increasing, which means that at -1, since I'm only going decreasing to only going increasing, it's like this graph, where I only have one location where I change directions. So I am going to have an absolute min. What is it at -1 to the 4th plus 4 times -1. -3 is -3 at x equals -1. Okay, and then I don't have an absolute max on that one because I just go always decreasing to always increasing. All right. And now f, or 4. F of x is 1 plus, or 1 over 1 plus x squared. Take the derivative. Maybe I should have just done chain rule. Whatever. Okay. What do I have? I can't set that. So the top equaling 0 is just x equals 0, and the bottom will never equal 0. So that one gives me no answer. So I can only get a 0 on the numerator. Number line 0, f prime, positive, positive, negative, positive. Okay, so it goes from positive to negative. So that would mean that what is f doing? Okay, so 0 is my absolute max. Is 0 in here is 1 at x equals 0. Okay? Easy? All right, let's do a little physics. You? Okay, let me teach you some physics. This is the mathy part of physics. Position, velocity, acceleration, displacement, distance, speed. Okay, position is given to you as s of t. It'll either, let's use units, meters. If your position is in meters, then the velocity is the derivative of position. So velocity is the first derivative of position. Because what happens when I take meters with respect to time and then I find the slope of it, I get meters per second, right? Okay, velocity includes direction and magnitude. For those of you that are in physics, you should know that, right? So direction, if it's positive, then it's moving up or right. And we're talking about one directional movement right now, not two directional movement. So we're either just going to be moving up or down or just going to be moving left or right. The negative means left or down. Okay? So if you're negative, you're going to be moving left if you're moving left or right, and if you're moving up or down, the negative would mean down. Speed takes away the direction, and it just gives you a magnitude, so that's still meters per second, but you're going to be always positive for speed. So if you ever want speed, just take the absolute value of velocity, because it takes direction out of it. Acceleration is the second derivative of position or the first derivative of velocity. So if I take the derivative of meters per second, I end up getting meters per second squared, or meters per second, but they usually say meters per second squared. Displacement is if you start in a position, let's say I start in one position, and then I go forward and then backward and then forward, my displacement is this. That's my displacement. It's how much I've moved from one point to another. Distance, though, is if I move forward to here and then backwards to here, then it's the sum of, that's a terrible bracket. It's the sum of both of those sections is distance. So your displacement is different from distance. Okay? Speeding up is when velocity and acceleration have the same sign. So speeding up doesn't just mean velocity is positive, because velocity is direction. And slowing down means velocity and acceleration have opposite signs. So when they are working together, they're moving in the same direction, so you're speeding up. When they're working against each other, then they're moving in opposite directions, and it means it's slowing you down. Okay? And then the particles stopped in changing direction when they're 0. Okay? Okay. Let's do an example. Here's a position. What's the position of the object at t equals 1? We just plug in 1. 1 minus 6 plus 9. 4 meters. That's it. Easy. Velocity, I have to take the derivative. So that would be 3t squared minus 12t plus 9. And then I want my velocity at 2. So v of 2 is 12 minus 24 plus 9 is negative 3 meters per second. So what's the negative mean? I'm moving left or down, right? Left or down. Speed of the object is take out the direction, so just 3 meters per second. Okay. And acceleration at t equals 5, now we take the second derivative, v prime of t, or is derivative of this, 6t minus 12, plug in 5. You get 18 meters per second squared. And then displacement. Okay, displacement means s of 5, my position at 5 minus my position at 2 is my displacement. So my position at 5 is 5 cubed minus 6 times 5 squared plus 9 times 5 minus 2 cubed minus 6 times 2 squared plus 9 times 2. And that ends up being 18, because this is 20 and this is 2. Okay? All right, let's talk about one more thing. If I were to find distance, that's the harder one. So I have to see if it changes directions at any point in between 2 and 5. So I want to find my velocity and set it equal to 0. Is 3t squared minus 12t plus 9. So I factor out a 3. And I get t is equal to, that would be 3 and 1. 3 and 1. Okay. So it changes direction at 3 and at 1. So here's the problem. 3 happens in between 2 and 5. So if I'm trying to find my total distance traveled between 2 and 5, what I have to do is I have to find my position at 2. So here's my t. Here's 2 and 5, and then 3 happens in between. So my position at 2 was 2. My position at 5 was 20. And then if I plug in 3, I'll get 0. Okay. So my position at 3 is 0. So what's my total distance traveled? 22. Because from 2 to 3 I traveled 2, and then from 3 to 5 I traveled 20. So you have to add the total distance traveled, so that equals 22. Which is different from this displacement. Displacement was 18 because I moved backwards and then I moved forward. Get it? Yes? Yeah? Okay. Your job is to do this next page. And then you're done for the day. I'll put up the answers so that you have them.